And this is a lovely question there. It kind of covers all the bases really. It has a bit of very basic factor theorem here. It goes on to a bit of integration, a bit of differentiation, and it finishes off then with a kind of a related rates of change question, which would have been quite challenging this year. Okay, but starts off always, and most of these questions are the same. Start off with a very, very simple place to start. So we want to show that we have a function here that tells us the temperature of coffee after a given amount of time. And the clue here is that they tell us that a cup of coffee is brewed at 95 degrees, right? And that might be kind of trivial looking at the start, but that's quite important because when we're trying to, that's our initial value. Okay, so at the start of as soon as the kettle is boiled, the coffee is 95 degrees. So when we're looking for A here, we want to show that we know that at 0 seconds, the temperature is 95. Okay, so if we sub 0 into this function, we can put it equal to 95. And now we can solve for A. And the good thing here is all this complicated bit here, A to the power of all of this just comes down to 1, right? Because anything to the power of 0 is 1. So take 20 from both sides. So we get A is 75, which is nice 5 marks to start. And then this is an interesting one then. So if you've seen this type of question before, this should be kind of obvious to you, but it mightn't be that obvious. So explain what the value of 20 in the formula represents. Okay, and it's only another 5-mark question here, right? But the key to this is that, right, we're dealing with coffee. Okay, and if we sub in a value of 0, or any value in here, it'll give us the temperature of the coffee. Now, if you'd imagine that eventually you're going to get if you type in 100 here, like 100 minutes, then this is constantly decreasing. So you'd think eventually it's going to go down to 0. Okay, well that can't happen because, like, if you leave a cup of coffee up on the counter for even an hour, 2 hours, 3 hours, it's never going to go to 0 degrees. Okay, because it's not going to freeze, obviously. So that's what that 20 does for you. So no matter what value I fill in here for t, for time, it's still the 20 means that it's never going to go below 20 degrees. Okay, so whatever way you phrase that, so at no time will the temperature drop below 20 degrees. That's what that 20 helps us do. You could say that 20 refers to the room temperature in this stage, or if you wanted to get mathematical of it, this function, the limit of this function is 20 degrees, right? It's never going to go below 20 degrees. No matter how big my value for t is, 20 is my limit, right? So it's the limit of the coffee's temperature, or the limit of this function. Okay, so those two were worth 5 marks each. I'll show you the marking scheme now in a second. Now, no calculus now yet, because it just says find the decrease in temperature after 10 minutes of brewing. So it started off, so here's my function, my complete function now. There's no, we have our value for A. We know that the temperature after 0 minutes is 95 degrees. So we just need to find the temperature after 10 minutes. Okay, so substitute 10 in there into the function, comes out as 53.36, and it's to the nearest whole number, so the decrease in temperature is 42 degrees. Okay, so if you look at those 3 questions there now, so out of 50 marks in this case, there's 20 marks there for very little. You might get a bit caught in this question here, right, if you aren't familiar with it, but there's very little maths involved now there for 20 marks. We're 2/5 of the way through the question here now. If we look at this question here, again, getting a bit more complicated here now, right, because we have our function, and we want to know at what time, at what value for t, will the temperature be 82 degrees. Okay, so that's what they're asking for us in English. After how many seconds? Actually, sorry, that should be minutes. So after how many minutes is the temperature at 82 degrees? So in mathematical terms, we want to know when is this function, what value for t will give us an output of 82? When is this function equal to 82? Okay, so just a bit of algebra here now. So we're putting the function equal to 82 and solving. Okay, and at leaving cert level, at leaving cert higher level, this should be a relatively easy equation to solve, right? It's an exponential equation. We're trying to get t on its own, so we get rid of the 20 first, take 20 from both sides, get rid of the 75 then by dividing both sides by 75, and this is where a leaving cert higher level student would have no problems. How do we get rid of this e? Well, we get the natural log of both sides. Okay, now there is another way of doing it using your rules of indices and things like that, but that's the way I do it anyway. So natural log of ln of e here just cancels, so we're left with this, and to get rid of this minus 0.081, we just divide across by that and type that into your calculator, and it comes out as 2.35 minutes. Now just watch out, look, it says to the nearest second. Okay, so that's it in minutes, 2.35 minutes. So how do we turn 0.35 just to 60 by 0.35, and it comes out as 21 seconds. So that's 2 minutes and 21 seconds. Okay, and again, look at your marking scheme here. So they were quite. Oh, they actually, interestingly, look, they actually accepted 2.35 minutes here, which is a bit of a Bit of a cop out here in it, but look, you got your full marks if you got that far. Now, if you got this far, equation in t with no indices or logs handled, so to get high partial credit here, you had to be able to deal with your logs, right? So if you only got this far, you're only getting your mid partial credit. You had to be able to deal with logs to get even high partial credit here. Now, in part C, then find to the nearest temperature the coffee. Now, look at this carefully. Find to the nearest the temperature the coffee has reached when T dashed of T is minus 4.05. Okay, and it tells us in this case that T dash T is the rate at which the coffee is cooling. Right, so they don't ask you to interpret much here, and you could do this question now, even if you hadn't a clue about what the derivative means in this case or anything. They kind of give you a lot in this question. It should be jumping out of the page here at you that you should be looking for the derivative of T here in this case. Okay, now just watch out for this. There should be no problem. The 20 is just going to go to 0. And when you're differentiating exponential functions, this stays exactly the same, but you're multiplying by the derivative of the power. So we're multiplying by that. Okay, and you can simplify that out. You can multiply the 75 by this decimal here. And it's an easy enough looking decimal here, which is that. Now we want to find, it says we want to find the temperature, but clearly here, look, we're obviously going to be putting the derivative equal to minus 4.05 and solving. Okay, so we'll put that equal to that. And again, it's another exponential function that you need to solve. Now, when you divide across by that, you end up with 2/3. Okay, so you can simplify it down to that. And again, natural log of both sides cancels the e, and we're left with this. Divide by minus 0.81, and we get this. Okay, now just let's look at what we have here now, right? So we put the derivative equal to that, and we got that. Now what that says is that after 5 minutes, right, the rate of change is minus 4.05. Okay, now we weren't looking for the minutes though. We were looking for the temperature, right? We want to know what the temperature of the coffee is. Okay, so we know that it's the rate at which it's cooling is that after 5 minutes, but what's the actual temperature? So you're thinking, what function am I dealing with here? Well, we want to know what the temperature is after 5 minutes, so you're subbing in the 5 into this original function here. Okay, now I substituted the whole function in here, or the whole decimal in. Now I think if you just substituted 5 in here, it would work out as well, because when you sub 5 into your calculator, it comes out exactly as 70 degrees. Okay, so just watch out, because a lot of people would have lost marks, would have just left it at that 5.00574 or 5, and they would have only got 8 marks, whereas it was actually the temperature we were looking at. Okay. Now, this is the hard question here then, right? The hard part of it, right? It's 10 marks. And anyone who's familiar with these type of questions should know it's a related rates of change, or 3 variables is what I kind of call it. And when you are familiar with these questions, that should kind of jump out at you, right? They mention rate of change a lot. They're on about they start with a rate. And no matter what way you do this, you should just make sure you have a select format for doing this. Now, the way I do it is I just say, okay, look at the very bottom line first of all. What rate are we looking for? So we want the rate of change of x. Okay. Now the rate of change of x, that's dx dt. Okay, the rate of change of x in relation to time, that's dx dt. And we're always given a rate as well. And at the very start, you can see the rate, the sugar cube dissolves, it decreases at a constant rate of 1/20 centimeters cubed per second. So that's the volume decreases at this rate. So we have a rate of dv dt. Right, that's the rate the volume is decreasing. Now, the big mistake people will make here is that it's decreasing. So it's going to be minus 1/20. Now, if you miss that up, it's not a massive error, right? You'll still get roughly the right answer. It'll just be the wrong sign, basically. So once we have these two things, then we can use our chain rule now to figure out what do we actually need to find. Okay, so we're looking for dx dt. We have dv dt. So what do we need? Well, we need dx dv. Right, because if we can get this derivative here, the dv's will cancel and we'll be left with dx over dt. So this purple one here is what we're looking for, dx dv. So we need to find that. Now, how do we find that? Well, we need a formula or an equation with v and x in it. Now, x is the side of the cube, v is the volume of the cube. Now, if you think of a cube, this is your ice cube here, a cube has sides of x. Well, what's the formula for the volume of a cube? Well, it's x by x by x, so that's just x cubed. So if the volume is x cubed, then now we won't get dx dv out of this, but we will get dv dx. dv dx is 3x squared, right? Just differentiating that. Now clearly here though, we're looking for dx dv. So dv dx is that, dx dv is that. Okay, so again, if you're not familiar with these type of questions, none of this is going to make sense. But if you're familiar with these type of questions, if you know the process, if you have that kind of schematic in your head, this should all make sense. We know we're looking for this, we have this, we now have this as well. So we can sub this now into that formula. So dx dt is going to be dv dt, which is minus 1 over 20, multiplied by 1 over 3x squared. So that comes out as that. And now, very finally then, we want to know the rate of change of x when x is 1/4 centimeter. Now, where did I get this 1/4 centimeter? Right, because in this case, they tell us that the rate of change when the volume is 1 over 64 centimeters cubed. Now, usually, whatever this value is, you just substitute that value in there and that gives us your answer. Okay, but the problem in this case is that they don't give us a value for x, they give us a value for the volume of the thing. Now, that's only one extra step and I didn't even write it in here. But if the volume is 1 over 64, well, the value for x is 1 over 4. It's just the cubed root of that. Okay, so look, that was just one extra step there. I didn't even write it in here, but that goes in there. So we actually substitute the 1 over 4 into this, and it comes out as minus 4 over 15 centimeters per second. So what that says is that this sugar cube is dissolving, and when the volume is 1 over 64 centimeters cubed, the sugar cube is dissolving at a rate of 4 over 15 centimeters per second. Okay, so a lot of people now mightn't understand fully what the answer actually means, but if you know this process off by heart perfectly, all those steps should make sense. Okay, and finally there, this is just your marking scheme, and again, it was 10 marks. It's hard to see where you were getting full marks here. I think if you just messed up the signs there, you were getting high partial credit. And I think if you got this equation at all, dx dt, look, see here now, if you get dx dt, if you got over the minus 1 over 60x squared, you got your full marks in it, or sorry, your high partial credit as well.